All right. So, guys, the quiz is going to be moved to the second half of class. All right. So the quizzes are no longer going to be in the beginning of class. So that way, if anybody needs extra time, it doesn't go and interfere with their actual learning of the next lesson. All right. So at 4 o'clock, that's when we'll start the quiz. Now, there's many of you who have decided not to do the STCW and 540 lab agreement. All right. If I have to go chasing you, you're going to start losing points, and I'm not too sure where it's going to come from. All right. So this is something you have to do. You don't gain points for doing it. You only lose points now for not doing it. So end of the day today. All right. This is your final warning.
Sorry, I'm
What's up,
late
Timothy?
today. I had things I had to take care of. Are we taking a quiz right now?
No. So the quiz is at the last 15 minutes class for people who may need extra time, so that way they don't lose out on the lesson. All right. So those of you who have not done both the STCW and the lab agreement, you have to the end of the day today. Otherwise, it's late. And I'm just going to start taking points away.
Did I put them in the right places for Okazan?
As far as they just have to be there, if they're in one or the other, that's fine. If you messed up and put the lab agreement and the STCW and the STCW in the lab, then there really should be no problem. As long as you have them. All right, so let's see. Tim, where'd you go? Yours specifically is a problem because I don't know what you did, to be completely honest. That's your lab agreement.
Sorry, I used an app on my phone to scan it and turn into a PDF to send to you. Why don't we just?
So just get that fixed.
I will.
It should be, I'll double check after class, but it should be, you can submit multiple times. So I'll double check both of those. All right.
Okay.
Is the first half of the class going to be like a review, or is it just going to be like another lecture?
What's up? Broke up.
Sorry. Is the first half of the class going to be like a review for the quiz, or is it just going to be like a lecture?
It's just going to be a lecture. If you guys have any last minute questions and we finish up early, then we could do that as well.
Okay.
All right. So, but considering you guys didn't have any questions about quizzes, about valves, last class, we were able to go into piping, which is what I had planned for today. And then we are going to basically be, sorry, I just read something in the chat. So basically, since you guys got ahead than the other class, if you want to use a little bit of time for a review, we can do that as well. All right. Let me just answer something. All right. Let me see. Piping. Where did we leave off? Did we talk about dies? Tap and dies. We did? All right. Did we talk about flanges? All right, that's where we left off. Right. Do this. Oh, and by the way, happy Friday, everybody. We're all set up. Now, I submitted to you guys in the PowerPoint section of 540, all right, in that modules, there's a whole section designated to piping, all right. There's some photos in there of different types of fittings as well as the actual PowerPoint, all right. So that is for your eyes as well, all right. Just some additional information because sometimes the fittings photos, I have to update them, are a little bit blurry and we could be doing better than that. All right. Did we talk all about threads, internal, external, how they're cut? All right. Did we talk about why this is necessary on the inside here? All right. So remember, it's just because we're cutting material. All right. That material needs to go somewhere. All right. Did we speak at all about flange? All right. So flanges may be threaded, welded, or cast into the pipe section. All right. You can see right here, this one is a screw flange. All right. You have the actual flange itself, this metal piece right here. This metal piece right here. All right. That's going to be threaded onto the pipe. We also have a flange that the pipe is spread out. All right. You can see it right there. And that's going to be stopping the flange itself. All right. And then we have a flange that will go on and it's welded on both sides. All right. So it doesn't have leak by going either way. All right. And then we have over here, which is a welded neck flange. All right. Where the entire flange goes deep outwards. All right. And it meets up and we do that V groove, that V weld. All right. So when doing flanges, all right, this is when we start using gaskets. All right. So for low pressure, we use a gasket that covers the entire face of the actual flange. All right. So when you see this sign right here, that is low pressure. All right. LP. These are made out of rubber, paper, flexible graphite, synthetics, stuff like that. All right. For you guys who go out and decide to ship after this, the best paper to be used as a gasket is chart paper. All right. Chart paper is pretty thick. It's thicker than normal paper. It does really, really good job at that. So if you're a mate in the class and an engineer comes asking for it, this is the why. This is the reason. All right. Going from there, we use bolts and nuts to screw it together. All right. They're tightened down. And here's the big thing. If you look at this, all right, watch how that grays in. All right. Notice how it's going in an opposite pattern of each one it goes in, it goes to the opposite. All right. That's done on purpose. It's called a star pattern. All right. Not only should you be inserting the bolts like that, but you should also be tightening them down in that pattern as well. All right. They're done that reason for why. Why would we want to go from 1 to 2 to 3 to 4 to 5 to 6 to 7 to 8?
So that it's even.
You want to go down even, exactly. If you don't, you'll end up with a flange that will look like this, and it'll just leak out of the top. All right, so always in what is called a star pattern, or if you have a picture that looks like that. All right. Now, let me erase some of this so you can actually physically see it. If you look, this is going to be HP, and it's different. All right. If you see, we have our flange piece right here, but it also has a piece of metal that sticks out. All right, you can see that here. All right, that's that ring right there. That's a physical piece of metal that's sticking out from the flange. And it's important because high pressure gaskets, they're smaller and they're used differently. All right, they're either metallic or flexitalic. All right, if you notice, the whole gasket isn't all the way around like it is there. It's a very thin spot that goes right in between those two pieces of raised metal. All right. Then they use studs instead of bolts and nuts. They still get nutted down on each side though. All right. You can use a stud on a low pressure side, but you can't use a bolt on a high pressure side. All right. All right, tube installations, tube connections are never straight runs. Deliberate bends allow for a reduction in length, which can occur as the tube is pressurized. All right, these incorrect ones right here. We are all training to be on a ship. So when you're on a ship and the ship hits a wave, that's my terribly drawn ship. All right. What happens in the engine room? What is different to the front of the vessel? Is the whole ship going to move in one whole piece?
Does the ship bend slightly?
So the ship will basically, it will contort, it will move, it will twist differently in each portion of the vessel, depending where the wave is as it's getting hit. All right. So when you walk down Shaft Alley, when you go on your first cruise this summer during high seas, right, the entire Shaft Alley will be twisting in different ways. Right. And it's why you can see it on the longest stretch of the ship. You can see that two different portions will be moving in two different directions, even though it's connected via steel. All right. That happens just naturally what's happening. All right. If this was connected like this between two bulkheads and we have that contortion going on, even not that drastic one, just by, cruising through the ocean on a nice day, what would happen to that spot right here?
It will bend.
It will bend and it will break. All right. This is just tubing. All right. Could be just copper tubing. It could snap here. It could snap on a piece of weak pipe. All right. Now, what we're doing here is it just gives that little bit of extra room for flexibility. All right. So we have to think about not only just the internal forces, but the external forces as well. All right. The internal coming from the pipe, whatever the system is, and the external of these things attached to bulkheads. Okay. So if you can, always have a bend. All right. Now, brazing or sweating. With this, who here has ever done any sort of copper soldering for piping or have done any electronic soldering?
Yeah, I've done some.
You've done some? Which one? Electronic?
Both, actually.
Both? Okay. Anybody else? No? All right. So when you are soldering two pieces of wire together, all right, it's that stranded wire. It's not solid. All right. What's the first step that you take with it?
Don't you twist it up?
You would twist it up so it would make a solid connection, right?
Yep.
So that's what you would do. You would take those two wires and you would twist them and turn them into a nice little knot. All right. Then you apply heat and then you would apply solder and you would make it one solid connection. But twisting that all up, twisting all those wires, right? How are we going to get solder into the deepest part of that wire ball? We want to make a physical connection, right? We're trying to run electricity, and we want to run electricity through a full piece of wire, right? That entire, whatever the diameter of that wire is, we want to run electricity through the entire thing, not just the outside, right? So how do we get solder into all those nooks and crannies? We're going to utilize something called flux. All right. And that flux is a certain type of material. It's like a gel-like material. All right. You would dip both ends of the wire into it, and then as you bring them together, that flux is all over. And what flux does is that it melts and turns into a liquid right below the temperature where solder becomes liquid. All right. And then as the flux begins to boil and liquid and becomes to a actual liquid, you add the solder to it, and the solder will flow into all the nooks and crannies because it wants to follow that heat. It wants to go to that heat, and the flux will be pulling the solder into all of those nooks and crannies. All right, so that bundle of wire that you've made, that bundle of wire that has now been twisted together, is one solid piece. All right, and that same idea of using flux applies to piping. All right, we want to make sure that solder gets into all of the nooks and crannies of our pipe that we're trying to solder. All right, so we utilize flux. So we start with flux, we dip it into both sides. So one side of our pipe, the other side of the fitting. We will heat the tube, and then we'll start to heat the fitting. All right, we will then add our solder. And once the solder is added, it will flow to everywhere where the flux was, and as the flux pulls it all in. And that's how we make that solid connection. All right? Does that make sense? All right, good. So that's sweating. And then we can use something called flared fittings. Flared fittings use what's called a flaring tube. All right, a flaring tool, not a tube. God, I've said that word too many times today. I have mine right in front of me. All right, this is one portion of it. You can see it has a slight taper to it right there. All right, let me stop sharing so that way you can see it easier. All right, it has a slight taper to it. All right, and then this is the top portion. You could see that it also has a taper to it. All right, the pipe will be inserted into the hole. You put the flaring tool. Come on. Put the flaring tool into it. Let's find a good angle right there. And you basically rotate it and smush the pipe to match both sides of that flare. Trying to move my finger there. All right. There we go. Is that brighter? All right. So that's basically what you're doing. You're clamping the two and trying to utilize that taper on either side of the tool. All right, so we have that taper that's right here, and it's going to match the taper that's on the inside of that pipe. And you're basically clamping the two together. All right. Now, these type of connections will fail quicker than other types. You put these in because you have to, not because you want to. All right. What's happening as we flare out the copper tubing? What are we doing?
Compromising the integrity of the pipe.
Exactly. We're stretching, we're manipulating it. All right. We're elongating it. We're thinning out the wall. All right. pretty much failure point for these things are right there. All right. They will last a while, don't get me wrong, but they will fail a lot quicker than other types of fittings. All right. Now, you will see these types of fittings around, used in different applications, but they're different from the copper type, using a flaring tool. All right. If you look to the bottom or underneath your, let me see, there we go. If you look below your toilet, things like that, if you look at the, trying to find it, I had a picture earlier up. If you look below your toilet, you look below your sink, you'll see that you will have flaring nuts, but it's a different type. All right, they're not elongating the material. Where is it? Come on. All right, that's good enough. All right, you can see how it has a different flare into it. This one actually has a gasket. All right, and you can see how it has a little bit of a flare to it right there. It's a different type of material. All right, it's different what they're doing on these than what we're doing with a flaring tool. All right. So the next thing that goes on is just a flaring nut. All right. And it will compress it downwards, and the actual physical metal that you've used to create in the flaring tool becomes your seal now. All right. So other types of pipe fittings that we have. All right. If we want to stop a piece of pipe, we have what's called a cap. All right. It uses internal threads. It threads onto the external threads of your pipe, and it stops the flow. And then we have what's called a plug. Plug utilizes external threads to thread into the internal threads of the pipe. All right. If we have two pipes of equal size, we use what's called a nipple. They can go all the way up until about 6 inches. You tend to have all of these fittings, all of these threaded fittings in what's called a Venmar. All right, it's just a big metal cabinet. All right. These fittings basically utilize external threads to go into two sides of internal threads. And then we have what's called a coupling, which has internal threads that thread onto the external threads of your two pieces of pipe. Now we have what is called a union. All right. If we have a piece of pipe like this, we have pipe 1 and pipe 2. If I rotate this pipe this way, what happens to pipe 2 if I rotate that coupling in that direction?
It gets loosened.
It gets loosened where?
Pipe 1.
Exactly. But that's only if pipe 1 is not able to free spin. If pipe 1 can rotate freely, then going in this direction will be fine. But if pipe 1 is attached to a bulkhead, or if it's attached to a piece of work or equipment or a long piece of pipe, it's exactly right. As you screw down and you go in this direction, trying to tighten it onto pipe 2, you will unthread it from pipe 1. All right. And that's where a union comes in. All right, so it's made up of 3 pieces. All right, we have one side that will thread onto one normally. All right, we have the other side, again, will thread onto the other pipe normally. And these are 2 separate pieces. And then we have a third piece, which is the collar, that will basically unite the 2 together. And it utilizes a metal-to-metal contact right here and right here. All right, and that metal-to-metal contact is where our seal is being created. These threads right here do not create the seal between these 2 pieces of this union. All right, it's metal-to-metal contact on these things. And I have better pictures that are cutaways. And you can look on to Blackboard. I posted them all, so that way you can see them for yourself. All right, the nice thing is that you can remove piping without having to cut out large sections. All right, you don't have to go all the way back to the original piece of piping. All right, all the way back on your equipment. This may be a 4-foot long piece of pipe with all of these different things on it in order to free up this pipe in order to put a coupling on. That would be ridiculous. So if you want to break a section of piping, all right, you want to break the 2 sections, you would use a union. All right. If you have unequal sized pipes, all right, this is a bushing. It utilizes external threads and internal threads. All right. And then we have what is called a union. A bell reducer. All right, the bell reducer has both sides are internal threads. All right, and they're unequal size piping.
They don't use metal to metal for that one.
So no, these are threads. This is all threaded connections here.
Oh, okay. So when it's all threaded, you don't need a metal to metal.
Yep. So there's going to be actually nothing in this area that would be making a seal. All right. So the 2 pipes are not going to be making contact with each other. All right. There's going to be a space here. I have some pictures after we're almost done with these slides. I have some pictures we can go through and see. And it'll make a lot more sense. All right. If you want to connect multiple pipe sections together, all right, we have what's called the T. All right, so there's our 3 connections right there. We have a reducing T. More often than not, you will see a reducing T that will be not looking like this. All right, this is nice if you want to like add chemicals to like a water stream or something like that. All right, but if you're going to have a reducing T, you will have something that fluid will be coming in this direction. You'll have a 1-inch piece of pipe coming in, right? And then it will be split off into 2 different directions where they'll be split evenly. So this would be a 1/2 inch, and this over here would be a 1/2 inch piece of pipe. All right, so the flow of water, whatever your fluid you're transferring, will go to 2 different directions evenly. All right. Or you can have it opposite, where 2 different feeds are going in at 1/2 inch, and they're going to come in together, and one won't have dominance over the other with flow. All right. So that's a reducing T. And then you have a T with a side outlet. I have quite literally never seen one of these. All right. Very specialty. All right. This is not something that you would have on a ship just on standby. All right. You would have T's and stuff. But a side outlet T, no, that'd be something you would specialty order. All right. So it has 4 outlets. You have 1, 2, 3, and then the 4th one right there. You have a cross. Again, the 4 outlets, 1, 2, 3, and then 4. We have a Y bend. All right. This one is utilized a lot in firefighting equipment. So look on the ship, you'll see these. All right. One side will have the hose, the other would be nothing. And then we have a 90 with a side outlet, or an elbow with a side outlet. All right. With 3 different pieces there. Now, if you want to change the flow in its direction, we utilize what's called an elbow. All right. Now, we have something called a street elbow. These you tend not to see. They're specialty, but not as much as like what I was saying earlier. All right. Very specific times you would use these street elbows. All right. The main reason is the distance from here to here is less than the distance from here to here at that center point. All right. It'd be utilized in a spot where you can't fit a regular elbow. All right. This street elbow gets inserted into another piece of pipe. All right. Whereas the elbow, the piece of pipe is here on the inside. So you may not be able to fit using a normal elbow. You might have another pipe running right here, and you can't put an elbow, a normal elbow, on the outside of that pipe. It won't fit. All right. So things like that, or you may have a piece of pipe up here, all right, that you normally wouldn't be able to fit because of that distance. That's what a street elbow is used for. They do have their place in the world. I've used them a couple of times. And then all elbows come in 45s, 30s, 90s, reducing, every single variant that you would imagine. All right. We have U-bends. We have U-bends with a little pipe at the back, all right, with a back outlet. Again, it can go either direction. All right. It might be a spot where you just add chemicals. That's really the only thing I can see these things being used. All right. Tube fittings, all the exact same, just in tube fittings. All right. Now, any questions on that? Like I said, I'm going to show you guys pictures of bell reducers and stuff, so that way you have a better seeing of that. All right. So let's do the bell reducer first. All right. So you can see on this bell reducer, all right, that there is those threads right there. All right. And then this, you can really see it. Look at that area in here. That's where you're not making that contact. All right. Same with on this one. You could see that those pipes are never going to touch each other. All right. That's your bell reducer. Now, here's some caps. All right. They come in all different shapes and sizes. Here's your fittings for your plugs. All right. Again, different sizes. What they function, what they do, how they get into their, how they get it inserted. All right. Here's some couplings. I don't know how a couple of nipples got in there. So now with, let's see, there we go. With nipples, all right, you'd be lucky if you'd get this version with a hex on it. All right. Most of the time, what you'd be looking at is this one over here. All right. You're just good luck getting a wrench on there without destroying your threads. All right. They would come down to about that size all the way up to, like I said, 6 inches. All right. All the way up to about there. And you'd have drawers of these. These are all pre-made. You buy them. All right. Now, let's see. Where'd the fittings go? All right. Pop this open and go to there we go. Now, we could see pipe fitting right here. All right. This is a union. It's cut in half. All right. You can see our metal to metal contact right here. All right. So we have 2 different pieces. Are you guys zoomed in like I am or no?
Oh, yeah.
Okay, good. All right. Because it seems like I've lost everything. So you could see the outside coupling on the outside here and here. And that's where that contact is being made. That's that seal. All right. So this thing has to be ultra tight up on each other. All right. It's really got to have some tension on there. You really can't tighten these things too much. All right. Now, like I said, all these are posted. All right. So you can see, again, that physical contact right there. All right. That's where that is making its contact. That's where that seal is. Again, this is what you can use to break 2 pieces of pipe. So you don't have to take apart the entire system. All right. Oh, that was sharing a different photo, of course. You guys got to tell me these things. There we go. That's the one I wanted to show you. All right. So you have that seal right there all the way around. All right. And this one is threaded on like we saw. The other piping was going to be, had to be welded.
That's the 3-piece union, right?
Yep. This is a 3-piece union, just like the last one I showed you. All right. And then this one, the third variant. All right. Again, this one you could see that it's going to have a metal-to-metal contact right here. Most of them don't have a seal ring. All right. But this one is totally different. It has a male, so the male gets inserted into a piece of pipe. And then over here we have a female, so the male pipe will get inserted into the female. All right. And then those will be welded. All right. So different from the other one, which would threaded, but it all doesn't matter. This one is still the collar, the nut is still threaded on, and it's that metal-to-metal contact, that seal that you're looking for. All right. Let's see, 339. So that is today's lesson. Like I said, you guys were the ones who were able to get through the other part easier. Wednesday, we don't have class Monday. We're having class today because of that. All right. Wednesday, we have our quiz on piping. All right. And then that is going to be our last class via Zoom. I'll re-explain this on Wednesday again. And I'll explain to you guys what you will need for lab, because lab will lab will beginning on the 25th. All right, that first week, and I'll be sending emails and everything else. All right.
So is this quiz just on valves?
Just on valves. All right,
Okay.
each quiz will only be on one section. All right. So, quiz Wednesday on piping. Today's quiz is only on valves. All right. Now, anybody want any sort of review or opened up for questions on valves or piping?
I just have a regular question.
Mm-hmm.
The labs won't start until we get back to school the 25th, right?
Yes, they're
Okay.
only going to start when we have in-person class, which is the 25th.
I just want to make sure I didn't miss it today.
Yep. Any questions? Any questions on piping? Any questions on valves?
What does the globe valve do again?
All right. So a globe valve, all right, these are utilized with either a stop valve or a throttle function, all right? They basically, you have the flow that goes from directly below. All right, so the flow goes from down here and it comes out of the top. That's always how these things flow, all right, no matter what, all right? They basically act the same way as a gate valve, where if you spin the hand wheel, the valve will rise. All right. Especially if you're going lefty loosey, it will come up. All right. Going down righty tighty will bring it down and it will seal. All right. But the difference is that these things can be used as a throttle function. Same thing as a stop valve as well. All right. Anything else?
Professor, could we just go over a visual for check valves when open when upstream pressure is greater than downstream, closed when downstream pressure is higher?
All right. Oh, I hate it when it does that. I just want it to start on the slide that I'm at. All right, so swing check and lift checks. All right, swing checks, when you have a flow going in this direction, all right, it will push open the check valve. All right, it will swing open that gate. All right, these things can be mounted horizontally or vertically. All right, due to the fact that they can do just because of this pivot arm right here. All right, any flow that comes out this direction and it can overcome this flow, all right, it will basically hit this, and gravity by that time will close this. And all of the pressure that's up here will keep this closed. All right. Now, any flow that comes in this direction, there's nothing stopping it from opening. All right, that's the beauty of these things. They literally only allow flow in one direction only, and they can be mounted horizontally or vertically. Now, a lift check utilizes like a plug. All right, this plug right here goes up and down in this sleeve, basically. All right, they're two different physical parts. The only way to remove the plug is to remove this bolt and to pull the cap off. All right, they are slid in together, but they are not connected. All right, the plug, this part right here, just rides up and down on that sleeve. So if we had this horizontally and gravity was being acted on this way, any flow that came in this way and pushed it open, well, it would open up and then there would be nothing to push that plug back down. All right, because gravity will just keep it in that spot. So then when the flow comes in the opposite direction, this plug's just wide open. All right, so that's why this can only be mounted horizontally. It can't be mounted vertically. And if you mount it upside down, God help you. Because you should really understand that that is needed to work only in one direction. All right. So swing check only can be mounted vertically or horizontally. All right. And lift check can only be mounted horizontally. All right. Anything else, guys? All right. So for the sake of keeping everybody on the same schedule, I don't want to start you guys 15 minutes into another lesson. All right. I'm going to open up the quiz. All right. One last thing. All right. Let me just open this up so that way you guys can start it. Remember, this is not open notes, it's closed notes. All right. No outside help. No phones, nothing.
So when we finish the quiz, do we leave or are we
Yep, you're
continuing
good.
afterward? Okay.
Good to leave. All right. Just keep it quiet. You don't have to say bye or anything like that. All right. So that way everyone else has the same quiet that you have. If you have a question, just ask.
You said the question. You said it was only 10 questions. How long do we have?
15 minutes.
And that's in modules.
Yep. Modules labeled quizzes. I'm going to open it up in 2 seconds.
Thank you.
And if you submitted to the extra time, it's already built in, so don't worry. All right. And it will force close on you. So watch your time. All right. It should be open. You should see it.
Professor, I just had a question.
Yep.
I finished. Is there a way to check what you see and see what you got wrong and stuff? Or
You'll see your one, not until everybody's completed the quiz, and then two, you'll see your grade after 4:30.
okay, cool. All right, thank you. Have a nice day.
Yep. All right. How you doing?
Hi, Professor. How are you?
So you just joined?
Yes.
All right. So, a couple of things. Why don't you kind of navigate with me on Blackboard? I'm going to share the screen so that way you can see it, but this way you can see what I'm seeing here. Zoom share. Enter student preview. All right, so a couple things. I'm Professor Callahan, Mr. Callahan, Mr. C, something along those lines. So I'll answer all three. Now, lecture info, I'm glad you found your way onto today's Zoom call. So that was good. I have a YouTube channel. So that way you can go back and you can listen to all of the lectures. So you missed 2 of them, Monday and Wednesday. All right. So if you go to the YouTube channel, click right there, it'll bring you right to it. All right. So I actually set up a playlist so you can see that there's the 3 p.m. lecture, 10 a.m., 11:30. There's only 2 in here because today's the 3rd lecture. I haven't posted it yet. I will after this. All right. So you can see all of everything else that everyone else has learned. All right. Lab. You're in a 540 lab course, right?
Yes.
Okay, good. That will start the 25th. All right. So don't worry about that until the 25th. When we get reconvene in-person classes, that's when you start going to lab. All right. So we'll talk about that in depth on Wednesday. All right.
Okay.
Now, go into the modules on the side. I'm going to keep this pretty organized. All right. First of all the PowerPoints are going to be released to you guys after pretty much midway through doing it, so that way you guys can have time to study. All right, so the valves PowerPoint is right here. Piping is in a folder because I want you guys to see all of these pictures. So I feel like they're important. All right.
Okay.
We'll go through the syllabus in a second as well. Now, quizzes will be in the quiz folder. All right, it'll basically be labeled as we go. Extra reading is just stuff that I find. If you're not getting the material, feel free to read it. All right, this valves, if you're confused on valves, Science Direct has some really awesome stuff. You can come up here. There's check valves, globe valves, nominal pipe size. It's just it's a great website that pulls from all of these technical documents. So feel free to use that. All right. Now, important information folder. This is a lot of good stuff for your side of things. All right. So here's the syllabus. Here's the remote learning document. So that's another place that you can find the Zoom link. All right. STCW and lab agreement we'll go over in a second. This is the 540 book. All right. I don't recommend getting the 540 book for this class. This is the one that will be suitable and fine. It will tell you all the information that you need to know. All right. It was written by Professor Youngren, who is no longer at the school. All right. So it's free to you. Here's some tracing symbols. These are symbols that I'm going to be showing and using throughout the class. All right. So you will have to basically learn these. You will have them memorized by the time you're done with this school. All right. Pretty much by your 2nd year here.
Yes.
So this is just for you. All right. Now here's 2 things. This is STCW. STCW form that you're going to have to sign and submit to me. All right. It opens up. So basically it's stating, have you taken any STCW classes here at the college, or
Yes.
are you grad or are you undergrad?
Okay, I was a grad before, but last fall I was a grad because I got my I completed my bachelor's degree.
Okay.
In Stony Brook University, in mathematics and geoscience.
Cool. Nice.
So
Congrats.
yeah, and when I went to the program, the deck didn't really fit me well, so that's why I switched to have an engine instead.
Understanding. Everybody makes that mistake once. I did it myself.
Yes.
So you're doing graduate degree.
Yes, I'm taking
with an engine license.
Yes, an engine license. Yes.
Awesome. Good to hear. All right. So this is the engineering STCW class policy. Pretty much every single 500 level class, which is 540, 541, go for it. That is all of our license classes. All right. So basically this goes out and it's for every single class. You have to sign it. All right. And it's the same thing I tell everybody. It's the same story. Last January, I re-upped my license. All right. And I was sitting in the class with the captain, the chief engineer, and the guy who teaches advanced firefighting at the school at Maritime.
Yes.
He was in the class with me, and we were doing advanced firefighting. So the man who teaches the class has to take the class. So no matter what, you have to do the time in the chair. All right, that's the whole idea here. All right, so if you miss too many of the classes, they're all outlined right here. We meet 28 times in a 14-week period. You get 3 classes can be missed. After 3, you fail automatically.
Yes.
Nothing I can do. All right.
Yes.
It goes through what's excused absences. So like if you're in the Navy ROTC, all that kind of other stuff, school-sponsored events. All I need is something from a person of authority. So if, I always say mommy or daddy can't write you a doctor's note. You got to get a doctor's note yourself. All right.
Yes. Yes.
But you can read through this document on your own time. And then I made it signable. So if you have Adobe, you can sign this through Adobe. All right. I'm sure you know about it, but to sign the document right up here.
Yes.
All right, cool. So both of these can operate in that aspect. All right.
Thank you.
Now, you were able to see that as I pulled it up, right?
Yes.
The PDF. Okay, good. Right. So now here's a contingency plan. In the event that 540 does not run, like the lab itself, because of these 2 events, I'm just having everybody sign this and acknowledging this is what's going to happen. All right.
Okay.
The 2 events is basically we never reconvene on the 25th. This is what the grading scheme will look like. All right. And you will have to take 540 lab at your next earliest semester it is offered. Okay. And then the other one is that if we do return, but then we get, we have to go back to online learning. Again, you will have to take it at the next earliest convenience. You would not have completed the lab. All right.
Yeah.
So quizzes, labs, and tests will result in that, name, signature, all that kind of fun stuff.
Okay.
All right. This is the syllabus. All right. 3 hours classes, 1 lab hour, 3 credits. There's no D or D plus, same as other STCW classes. Again, introduction to practical marine engineering. Don't recommend it. I really don't. It was a book when I was here at Maritime. I just don't think it's good. I have to put it because I don't have anything better at the moment.
Okay.
So if you can get it for like maybe $50-$20, buy it. It wouldn't be the worst thing, but for the $150, it's not worth the money. All right. Office hours. There's my email. Don't email my student email. I don't look there. Online appointment only. All right. So if it's in between these hours, I guarantee you, if you email me within a few minutes, you will get an email back.
Okay.
Giving you a Zoom link to join. If those times don't meet when you can meet, email me. I'm more than willing to help anybody during the outside hours of that. All right. Sometimes it's just that I might not be able to. Okay. So days in class meetings, I'm trying to get these rooms moved when they're fully updated. Probably next Friday, I'll re-upload a new syllabus with the new rooms. All right. Cell phones obviously can't be used. All right. This explains again the STCW policy. Grading. All right. So lab will be graded via this class as what is known as a plate. A plate is a tracing. All right. It's a line diagram. We'll go into more of it when the time comes, but it's worth 10% of your grade. All right. Quizzes are worth 15%. So at the end of all of these, you're going to have 11 quizzes, all averaged together, 15% worth. All right. Exams 1, 2, and 3, each one are 15%. Final exams worth 30. This is the grade assignments. Again, 69.9 is an F. Makeup policy, I don't have any. There is no makeup policy. Don't get it. There is nothing. Can't do anything. The only time there's an exception to that is like funerals, sicknesses, stuff that's been mentioned by the STCW. I pretty much follow that. All right. So if you have an excused absence, then that's an excusable makeup. All right. Quick synopsis, I tell everybody else. First exam will cover valves, piping, pumps, and pump ops. All right. And then second exam is freshwater, refrigeration, HVAC. Third exam will cover electricity and hydraulics. And then steam plant and shipboard operations is going to be a nice transition into our final. And that way we get it as close as possible to going on this cruise. All right. I don't know if you get accommodations like extra time on class, anything like that, learning disabilities. I only accept them from Dr. Anderson. All right. So get her to email it to me. All right. I can't ask for it. You have to do it. I don't know if you do. And then you'll get it. Do you have it or no?
No, I do not.
Okay. And then academic category policy, again, just don't do it. All right.
Okay.
So stop that. And we'll go into this once again. So that is all of that. Let me check. Let's look. That is it. All right. So Wednesday, can you come to my office hours?
Yes.
All right. So Wednesday, you'll come to my office hours. I'll email you a link. What time? 1:30?
Let me see.
Start of it. What's best for you? It's only going to be a 15-minute quiz. So
Okay.
if you want to take it right before we go into class, we could do that too. Or if you want to take it early, so it gives you time to study for piping.
Okay. Wednesday, it's going to be 1 o'clock. It's fine.
All right. So let's shoot for 1:30. That's when I think the start of my office hours are. Whatever the start of the office hours, I'll be there. All right. I'll email you a link.
Okay. 1:30 is fine.
Okay. Let me write your name down so I'll remember to email you. So we'll do the valves. Then I have another student that will be coming as well. All right. And then we'll go into piping. So you have full ability with, like I said, those PowerPoints. If you have any questions, email me. If you want to sit for office hours on Tuesday, email me. All right. If you're confused about anything. All right.
Thank you.
That was a bad pen. All right. So 1:30 on Wednesday. All right. Feel free to watch any of the other lectures as well.
Thank you.
All right. That's all up to you if you want to do it.
I will do it. I will do it. Thank you.
All right. Like I said, any questions, give me a ring.
Thank you so much.
Have a good day.
Same to you. Thank you. Bye-bye.